Hello, this is ABBA International Education and Leadership Academy. I am here to introduce you to Calclass, but before we get started with Calclass, I want to introduce you to our organization, which is called ABBA International Education and Leadership Academy. We are providing academic support to students who are doing IB at Cambridge, and we really tutor online or in person. We're providing online or in-person tutoring. We're also tutoring all kind of subjects, including French, Swahili, Arabic, computer science, music instruments such as piano, guitars. We have professional tutors who can help with this subject. And we're actually tutoring students or kids from 3 years old all the way to high school. And we're also helping adults who are preparing for specific exams, maybe language proficiency exams or standardized exams. We have professionals who can provide that kind of support. We are actually based in Africa and in Hong Kong. We are based in Africa and in Hong Kong. And to be able to connect with us, you can actually text us or call us on these WhatsApp numbers, which are displayed on your screen. These two are WhatsApp numbers, so you can connect with us by texting us, calling us on these two numbers, and then we'll walk you through the process of hiring a professional tutor from ABBA International Education and Leadership Academy. We are working with a team of very professional people who are very passionate and competent in tutoring. They have done tutoring for a long time now, so you can imagine that they have helped many students to pass their Cambridge exams like IGCSE, AS, and A-level exams, and even those students who are doing IB diploma. You can also connect with us on Instagram, Facebook, and YouTube, where we share different content about this organization. So thank you for that. Now we can get started with our today's topic, which is Calclass. Before I get started with Calclass, I want you to know that Calclass is a very important topic, especially for students who want to pursue engineering or study higher mathematics in university. So you have to be very familiar with this subject. Now let's get started with Calclass. So before I dive into Calclass, let me take you back to coordinate geometry. I want to introduce you to our organization, which is called ABBA International Education and Leadership Academy. We are providing academic support to students who are doing IB at Cambridge, and we really tutor online or in person. We're providing online or in-person tutoring. We're also tutoring all kind of subjects, including French, Swahili, Arabic, computer science, music instruments such as piano, guitars. We have professional tutors who can help with this subject. And we're actually tutoring students or kids from 3 years old all the way to high school. And we're also helping adults who are preparing for specific exams, maybe language proficiency exams or standardized exams. We have professionals who can provide that kind of support. We are actually based in Africa and in Hong Kong. We are based in Africa and in Hong Kong. And to be able to connect with us, you can actually text us or call us on these WhatsApp numbers, which are displayed on your screen. These two are WhatsApp numbers, so you can connect with us by texting us, calling us on these two numbers, and then we'll walk you through the process of hiring a professional tutor from ABBA International Education and Leadership Academy. We are working with a team of very professional people who are very passionate and passionate and competent in tutoring. They have done tutoring for a long time now, so you can imagine that they have helped many students to pass their Cambridge exams like IGCSE, AS, and A-level exams, and even those students who are doing IB diploma. You can also connect with us on Instagram, Facebook, and YouTube, where we share different content about this organization. So thank you for that. Now we can get started with our today's topic, which is calculus. Before I get started with calculus, I want you to know that calculus is a very important topic, especially for students who want to pursue engineering or study higher mathematics in university. So you have to be very familiar with this subject. Now let's get started with calculus. So before I dive into calculus, let me take you back to coordinate geometry. Let me take you back to coordinate geometry. I hope you remember you remember the process of finding the gradient of a straight line. This is x axis, this is y axis. I'm going to walk you through very quick. So let's say I have a point A here, and I have another point here, point B. I'm going to draw a straight line to connect point A and point B. We learned that we can actually find the gradient of this straight line AB, and the gradient of straight line AB is actually constant. It does not change. So if I pick another point here, let's say point C here, I put here, and then I pick another point here, let's say D, and I put here, the gradient of line segment AC must equal the gradient of line segment CD, and also must equal the gradient of the line segment DB. That's the idea that the gradient of a straight line does not change. Okay, now let's say this point A here is x1, y1, this is a coordinate, and point B has coordinates of x2 and y2. We can find the gradient of AB by applying this method, which is called change in y over change in x. Change in y means the difference in the vertical distance here. Change in y, that will be y2 minus y1, and that's the same thing with our change in x. Change in x means the difference in the x coordinate, which should be x2 minus x1, because this point here is x2, this is x1, and this point is x2. This point here is y1, this point here is y2. So the difference here is what we call change in y, and the difference here is what we call change in x. So the gradient is the ratio of change in y over change in x. You can write this as y2 minus y1 divided by x2 over x1. Also, we learned that there is a way that we can express the equation of this straight line in a standard form, which is y equals to mx plus c. Y equals to mx plus c. I'm not going to derive this equation, but I hope by this time you should know this. M is our gradient or slope, and c is our y-intercept. So you know this stuff. I'm not going to spend time here. Let me go to the next part. So I want you to remember that the gradient of a straight line is a constant, which can actually be calculated by using that method, change in y divided by change in x. Now, what if you want to find the gradient of a curve? Let's say consider consider the function y equals to x squared. We know this is a quadratic equation, and then it's going to give us a curve. If we're going to graph, this is going to give us a curve. This is a quadratic equation. Now you can even find a few points here which are on this equation or this function. Let's say pick 0, 1, 2, 3 for our x values. See, y equals to x squared. So if x is 0, y must be 0. If x is 1, y must be 1. 1 squared is 1. If x is 2, y must be 4, because 2 squared is 4. If x is 3, y must be 9, because 3 squared is 9. So we can actually have a graph of this, which is actually a curve. So let me draw another xy plane. Okay, sorry, xy plane. Okay, so this is my x, this is my y, and this is my x axis. So I can have a curve that looks like this. Okay, let me draw this again. I can have a curve that looks like this. This is a curve, this is not a straight line. So what is special, and what is special about this and this, is that the gradient of this curve is not constant. The gradient of a curve is not constant. So we cannot just pick 2 points here. We cannot pick 2 points here, let's say B and A, and then say that and then use those 2 points to find the gradient of this curve. It doesn't work that way. So we can actually estimate the gradient of this curve at a certain point, because the gradient is not constant. It means if I have a point here, let's say I have a point here, point A, I have another point here, point B, and then I have another point here, point C, and then this is point D. The gradient M at point A is not equal to the gradient at point B, does not equal the gradient at point C, or the gradient at point D. It can be different, or it can be, some of these can be the same, but we're not expecting all these points to have the same gradient. The gradient is not constant. That's what I'm trying to explain here. Now, how do we find, let's say, the gradient? Now, how do you find the gradient of a curve at a certain point? As I said, we can only estimate. Let's say this is point, I'm trying to find now the gradient of this curve at point B. What I can do now, I can draw a tangent line. So the process, we can draw a tangent line. And use it to estimate the gradient of a curve, at that point. So let me draw it. Make sure you're using a ruler. You have to draw a tangent line at point B. A tangent line is the line that is going to touch this curve only at B. That's the meaning of a tangent line. Okay, it doesn't have to be perfect, but just make sure that you're using a ruler to draw your tangent line. Okay, let me redo this because it's not touching. Okay, this is my tangent line. So we can actually use this tangent line now to estimate the gradient of this curve at point B. How do we do that? We do that by finding the gradient of the tangent line, as I said it. To draw a tangent line and use it to estimate the gradient of the curve at that point. So I can say this point here of this straight line, I can say this is point A, which is x1, y1, and this is point B, which is x2, comma, y2. These are real numbers, can be any real numbers. So the estimate gradient at B, the estimate gradient of this curve at B should equal change in y over change in x, or should equal the gradient of this straight line, or this tangent line, which is y2 minus y1 divided by x2 minus x1. So we can use the gradient of a tangent line to estimate the gradient of a curve at a given point. This is just an estimate, it's not an accurate answer. So let me give you an example here. Okay, let me give you an example, and again, let's use this function. Consider f of x, which is x squared. Okay, let me draw real quick. Okay, I'm going to use this point here. Let me say this one is 2, this is 2, this is 4, 6, 8, 9. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, keeps going. This is x-axis, this is y-axis. Remember to label your axis. Okay, this is 10. Okay, I'm skipping 2's in the y-axis, and then I'm just counting in 1's in the x-axis. So I'm trying to graph this function y equals to x squared. So when it's 0, we're expecting this to be 0. When x is 0, this is also 0. As a matter of fact, you can just use this point here. I already have this point here. Okay, I'm just going to write it here for your reference. This is x, this is y. 0, 1, 2, 3. So this is 0, 1, 4, 9. So 0, 0, 1, 1. 1, 1 should be here. Then 2, 4. 2, 4 here. Then 3, 9. 3, 9 here. So it looks like this. It looks like this. But let me make it bigger. So let me make this bigger. Let me make this bigger. Okay, let's make this bigger. Okay, so let's say this is 1. Okay, let's say this is 1. Let's skip 3's. 2, 3. Okay, this is better. Then here let's just count in 2's as before. 2, 2. Okay, 2, 4 here. 6, 8, then 10 here. It should be better than 0, 0. We have this point here. Another point is 1, 1, which must be here. Then another point is 3, 2, 3, 2, 4. X is 2. Y is 4. And the last point is 3, 9. So X is 3. Y is 9. That should be here. Now you can just join this point. You can join this point. Remember, this is a curve, so don't use a ruler because you're drawing a curve. So this is my curve. Now let's use this curve to estimate the gradient of f of x at one of the point, let's say point 2, 4. We're using this graph to estimate the gradient at which point? 2, 4. So 2, 4 should be here. This is this point here. So what you're going to do is just to draw a tangent line again. Remember, we're using tangent line to estimate. So I'm going to draw my tangent line. Make sure you're using a ruler. Okay. Then I'm going to pick 2 points on this straight line, on this tangent line. Remember, to find the gradient of a tangent line or any straight line, you need 2 points. You need 2 points. You need 2 points. So you can find your points now. Okay, I'm going to pick any point here. I'm going to pick this point here, and then I'm going to pick another point here. Make sure the point you're picking are on the tangent line. They have to be on the tangent line. Okay, so this point here, I can say it is 3, and this is 9. Let's say 9.5. No, not 9.5. The y coordinate here, this is 7, it will be 7.5. And this point here, let me call this point B. This is point A, is point B. Let me call this one point A. Okay. So point A here. A here is let me just round it to be, call them it's a little bit hard because we are actually skipping in threes. We're actually skipping in threes, so you can tell that this one, the middle of here is going to be 1.5. So we can pick this point here to be between 1 and 1.5. 1 and 1.5, which is 1.25. So we can say x is 1.25, and y is straightforward 1. So the estimate, give me the different color. So estimate gradient, or estimated gradient, equals to change in y over change in x, which means y2 minus y1 divided by x2 minus x1. The y2 value is 7.5 minus y1, which is 1, divided by x2, which is 3 minus 1.25. You can pause the video and do the math. It's a simple algebra. But if you do this one, just plug in your calculator, you get something like this. I'm rounding this off to 2 decimal places. 2 decimal places. This is rounded to 2 decimal places. 7.5 minus 1 divided by 3 minus 1.25. Okay, so this here 3.75, this is our estimate value of the gradient of this curve at this point, at point 2, 4. It's just an estimate, it's not an accurate answer. So to be able to find or to get the more accurate answer, we need to move very closer to this point, to point 2, 4. We need to choose points which are very closer to this point 2, 4. So I have to go higher, and here I have to come lower. I have to choose points which are very closer to this point here to make sure that my answer is more accurate, because we're finding the estimate of the gradient. And that's what we're going to be doing in the next section. We're going to see how we can get more accurate with finding the gradient, with estimating the gradient of a tangent line. How do we get more accurate? Now I'm going to introduce you to another concept, which is called limit. Limit means what is the value of the gradient of this tangent line as we get closer and closer to 2. What is the value of the gradient of this tangent line as we get closer and closer to 2? So we're going to see how we can actually use mathematics and algebra to arrive to that conclusion. So now we're going to talk a point. We're going to I'm introducing you to a concept which is called gradient of a tangent as a limit. Again, consider I have a function, and this function looks like this. Let me draw. Okay. So if I want to, let me draw a curve here again. If I want to find the gradient of this curve at point P, the gradient of this curve at point P, the gradient of this curve at point P, I need to have a tangent line. As we saw, we need to have a tangent line. But again, I said we need to make sure that we are limiting this tangent line, or the gradient of this tangent line, very close to point P. So if I'm going to draw a tangent line here, I'm going to draw a tangent line. And I need to find the gradient of this curve at point P. I need to have at least another point. So let's say I put this point here. Let's say we have another point here. Let me use a different color. We have another point here. We have another point here. Let's say this is point A. Then we have another point here, point B, and then point C. Point A, B, and C. So I can draw a line here from P to A. I can draw a line. You see, I can draw a line from P to A. I can draw another line here. As a matter, let me show you. I can draw a line from P to A. I can draw another line from P to B. I can have another line. Let's call this C. We can have another line here from P to C. So if you are trying to really have a good estimate of the gradient of this curve at point P, we have options to find the gradient of AP, AP of AP, or BP or CP. But again, I said you need to choose points which are very close to point P. So the good option here is going to go with is to go with point A. PA is going to give us a good estimate, a good answer of this gradient of curve at point P. Now let me draw another graph here, another XY plane to help you. Okay, this is X, this is Y. Now let me go ahead. Let's say consider this. Let's say so the function is y equals to, let me use f of x. Y and f of x is just different ways of expressing functions. Let's consider this x squared. We have a graph of x squared. We saw this graph of y equals to x squared. This is here. This is the graph of y equals to x squared, or f of x equals to x squared. It looks like this. It squares the x variables to find and give us the y values. We square the x variables or x values to get y values, and it is a curve. So let me go ahead and draw this here again. Okay, let me try again. Make sure you're taking your time as you're drawing this. Make sure you're taking your time. You're drawing these things accurately. So this is the function y equals to x squared. This is the function y equals to x squared. Y equals to x squared. Now let's say now I have a point here. I have a point here. Let me call this point x. And then I have another point here. Let me put it here. I have another point here, but the difference or the distance between x and this other point is h. So this point here, I call it x plus h. To mean the difference, if I take this point, the second point, x plus h minus x, the difference here is h. So this point here, I have 2 points here. So if I have x here, you can imagine that here I'm going to have f of x, right? Because that's how we use x values to find y values. So if my x value is x, to find x values, to find y value, I have to plug in x in the y function, which is x squared. So as a matter of fact, this one has to be x squared. And another point here, in this point here now, x plus h. I'm going to draw a straight line here. Okay, I have to make sure that it is stopping somewhere, because this point is here. So I want to make sure that's there. So if I'm going to draw a line here, I gotta make sure that okay, that's good enough. Okay, you can give it another try. All right, now let's continue. So this point here, my corresponding y values is going to be f of x plus h squared, right? I mean this one, f plus, there's no need to put a square here. If I need to find the x value here, the y value here, by using x plus h, I have to plug x plus h in my f of x function to find the y value. As a matter of fact here, the y value here is going to be x plus h squared. I hope you understand what I'm trying to do here. Now, if I was to join these 2 points, this point and this point here, I'm going to get something like this. Make sure you're using a ruler. Okay, I'm going to get something like this. This is good enough. So if I was to find, now let's say this is point here, this point I call it point P, and this point here is Q. I want to find the gradient at point P, the gradient of this curve at point P. So consider the gradient at point P. How do I do that? Well, you can see I have a straight line here. I have a straight line PQ. I have a straight line, so we can actually find the gradient of this straight line PQ. But again, we saw that's just going to be an estimate. So the best way is to move Q very close to P. If you move Q very close to P, we are going to have a better estimate. So if Q, let's say if Q was here, this would be a better estimate. Or if Q is here, this is even better. So you're trying to condense Q all the way to P. You're trying to move it very close to P. But do you have a mathematical way of doing that? That's what I'm going to explain with you in the next few seconds. Yes, we can actually, we have a mathematical way of doing that, and that is called limit. We can find the limit of the gradient of this line PQ. We can find the limit of the gradient of line PQ. The limit of the gradient of PQ means what is the value of the gradient of the line PQ as we move very close to P. As we move very close to P. So that's what I'm going to write here now. So the gradient, now if I was to find, let's say now if I was to find the gradient of AB, just to make sure that we are getting this. Gradient is change in y over change in x, which we said is y2. So this is AP, this is PQ. So gradient, I can just use M to show the gradient of line PQ. That would be my f of x plus h minus f of x. This is my f of x plus h, this is my y2 value, and f of x is my y1 value, divide by x plus h minus x. If you simplify this further, you're going to have something like this. H. So this is the gradient of line PQ. So if I want to use this gradient of line PQ to find the gradient of the curve at point P, I have to find the limit. So I'm say find the limit of the gradient to get the gradient of the curve at point P. So we're trying to find out now what happens as you move very close to P. That means you're also moving x plus h. We're moving it back to P. We're moving it to P. And you're also moving we are moving f of x h back to this. We're trying to get to P. What happens here, right? We're moving down to P. So we're going to find the limit of this gradient. We're going to find the limit. Remember I said the gradient, I'm writing it here again, is f of x plus h minus f of x divided by h. So we can actually find the limit. And the limit of this one should give us the gradient of this curve at point P or any other point. Gradient of curve at P should be the gradient of the curve should be the limit, should equal the limit. I'm just going to the abbreviation here. Should be the limit of f of x plus h minus f of x divided by h. But as this h, remember the difference here, this horizontal distance here, this is h. This is called h. So you're moving this h very, very close to this one. So we are reducing, or we are decreasing h value. We're trying to get it 0. So trying to find the limit of this gradient as h tends to be 0. It won't be 0, but as h tends to be 0. And this should give us the gradient of the curve. The gradient of the curve is also denoted by this sign. This is called f derivative. Now this process here, the process of finding the gradient of a curve, the process of finding the gradient of the curve is called differentiation. So right now here what you're doing, you're trying to differentiate. So the symbol, this one on the right side, is called f derivative. The f derivative, the gradient of the tangent line at a certain point in a curve. Now let's go back and say, and use this function, Now let's say f of x is x squared. So let's use this one let's find the limit. Let's find the gradient of this. Let's find the limit of the gradient of the tangent line of this curve. for the gradient here, gradient equals to f of x plus h. Okay, sorry. Gradient equals to the limit of f of x plus h minus f of x divided by h as h tends to be 0. Okay, so this gradient now, let's just call this one now f derivative, equals to the limit of f of x. F of x, we're going to remember the function is x squared. So f of x plus h, we are plugging this into this function. So x plus h squared minus f of x. F of x, this is the original function, x squared, divided by h as h tends to be 0. Now we are going to actually expand this. This is the same thing as x plus h times x plus h minus x squared divided by h. I hope we can do this. So this equals to the limit of x squared plus 2ah plus h squared minus x squared divided by x. Okay, now what do we have here? These two values, x squared and x squared, they cancel out, so we are remaining with 2 plus h, 2ah plus h squared over h. We can also go ahead now and simplify by dividing every number on top by h. So 2ah divided by h, that should give me 2a, plus h squared divided by h, that should give me h. So as h tends to be 0, the next step is just to plug in h as 0. So the limit equals to 2a plus 0, which is 2a. This a can be replaced by any variable, which is, in general, we set it as x. That means the f derivative or the gradient of this curve at any point is 2x. So we can actually use this one to find the gradient. Let's say we can find the gradient of f of x equals to x squared at x equals to 6. We can actually do that. How do we do that? We take solution here. We say f derivative, this is our gradient of this curve, equals to 2x. X here is 6, so you plug in 6 here. 2 times 6, you get 12. So this is the gradient. Another example would be find the gradient of f of x equals to x squared at x equals to 3. Solution: you have your f derivative, or the equation for the gradient line, which is 2x. Now x is 3, so you plug in 3 here and you end up with 6. Now you can see what I was trying to say here. You see, the gradient of this curve here is 12 when x is 6, and the gradient of this curve is 6 when x is 3. You can see here the gradient is changing. This is what I said about the curves. The gradient of the curve is not constant. It changes, keeps on changing. And as a matter of fact, if you come back here to this line here, to this graph here of x squared, if you come back to this graph here, we see how the gradient is changing. This graph is getting steeper. So as the graph is getting steeper, we're expecting the gradient to increase. That's why the gradient at 3 is 6, and the gradient when x is 6 is 12. I hope you understand. As this graph is getting steeper, the gradient is increasing. That's idea. Okay, now we're going to just solve a few questions here by using this limit thing that I just explained here. So we can use the limit to find the gradient of a curve. And I want to just clear one thing here before we continue. This line here, PQ, this is actually called a secant line. This is called a secant line. I'm not going to talk that much about this, because I'm pretty sure this is not your level yet. So this is called a secant line. So we can find the limit of a secant line and use that limit as the gradient. The gradient of a secant line, the limit of the gradient of a secant line is the same as the gradient of the curve. So now let's solve a few questions. Example here. So let's call this example 3. Find an expression of x derivative when f of x equals to x cubed. Find an expression for f of x derivative when f of x is x cubed. So how do we do this question? First, I want you to understand, what is this? You see this this sign, this little line here. I want you to understand it. What is this? Well, this is what we're trying to find. This is an expression of the equation of the gradient of this curve. This is an equation of the gradient of this curve. Because we know this is a curve, so the gradient of this curve is not constant, so it's going to be changing. So we need to find an expression for that gradient. So again, our method is very similar to what we did. F of x derivative or the gradient equals to the limit of f of x plus h minus f of x divided by h. We are finding the limit of this gradient as h becomes 0, as h tends to become 0. So I'm just going to plug in here. Remember the equation that we're using here, f of x is x cubed. So the limit as h tends to be 0 of f of x. So f of x plus h f of x plus h, this is x plus h cube. We are replacing x with x plus h. So f of x plus h is x plus h cube minus f of x, which is x cube, divided by h. Now the next step is just to do some algebra to find the answer. So we know this cube thing is the same as this one. Can I rewrite this in this way? As h tends to be 0, now we can expand. You expand this. This one, we know this is x squared plus 2ah. Okay. Sorry, the mistake here. Okay, I'm trying. Yeah, I used a different variable here. Just going back to this example here to correct something here. Okay, we didn't have a. This is supposed to be x. So it is 2xh or hx, like this. So let me replace this a here with x. Okay, I'm used to a. That's why I like using a's a lot. So it's 2xh, and as we keep going here, 2xh, we replace this with x, so it's just 2x. So we'll end up with just 2x, not a. So the limit here is just 2x. Okay, so let's avoid this mistake here. So x plus h squared, I'll get x squared plus 2xh plus h squared, bracket x plus h, this whole thing divided by h, as h tends to be 0. Now we can go ahead and simplify this more. We can expand it more. I hope you know how to expand this. I hope you know how to expand it. I'm just going to do it for you. So to expand this one, I'm just going to take the first variable, which is x squared. I'm going to multiply it by every variable here. It's going to look like this. It's x squared times x plus h, then plus the next variable times everything in the next bracket here. So 2xh times x plus h, then plus h squared times x plus h minus x cube divided by h. Now it should be easier. So the limit now, this expression becomes x cube plus x squared h plus 2x squared h plus 2xh squared plus x h squared plus h cube minus x cube, this whole thing divided by h. And now we have to simplify. So we know this and this, they cancel out. Then we can just divide, we can actually divide everything by h here. We can divide everything by h. So divide this by h, everything by h, because there is h everywhere. So we are going to reduce everything here by h. Okay, let me use the same pen, the same color. Okay, when you divide x squared h divided by h, you end up with x squared plus 2x squared h divided by h. This is 2x squared, and this one 2xh squared divided by h. This is 2xh, and then xh squared divided by h should be xh, and h cubed divided by h is h squared. As h tends to be 0, now we can just plug in 0 in the place of h. We plug in h equals to 0. So when you see h, just plug in 0. So this limit is going to be this: x squared plus 2x squared. Here we're plugging in 0. X times 0 plus h squared, which is 0. Then if you do a little bit of math here, you're going to end up with something like this: x squared plus 2x squared. Now you can actually go ahead and simplify this, right? I mean, x squared plus 2x squared, it should be x squared plus 2x squared should give us 3x squared, as h tends to be 0. So what's the limit of this? This is the constant limit, so the answer is just 3x squared. So the gradient of this curve, is 3x squared. That means we can use this equation of the gradient to find the gradient of this function x cubed at any given point. For example, what I want you to try to do this. What is the gradient? What is the gradient of f of x equals to x cubed at x equals to 4? I want you to pause this video and try. Remember, we already have the function. We already have the equation of the gradient. We know what the we know the expression for the gradient. We have the expression for the gradient. We can just use that expression to find the value of this gradient when x equals to 4. Now solution, because I know that the expression for the gradient of this function is 3x squared, I can just go ahead and just plug in x, which is 4. I can just plug in 4. As a matter of fact, you're trying to find the gradient when f is 4, so we can put 4 here. You're trying to find the value of this expression when x is 4. So 4 squared is 16. 16 times 3 is 48. So this should be the answer. Again, you can see if you pick x to be 0, the gradient is going to be 0. You can tell that the gradient is it keeps on changing. The gradient keeps on changing. Okay, let me see. Let me give you one last example, then we'll stop here for today. One last example. We'll continue this with this topic. Next time we'll be differentiating polynomials. We'll be looking at higher functions. So this is my last example. This is example 4.